Assalamu alaikum students. So I hope all of you are doing well. Let's start with today's past paper IGCSE Physics 0625 paper 4 variant 1 May June 2024. This is a 1 hour 15 minutes ka paper. Let's start with that. So let's zoom in a bit here. Yeah, perfect. A long tube contains oil. Perfect. A small ball is held at rest. Okay, so your initial velocity is 0. Okay, at the surface of the oil. At time t is equals to 0, the ball is released and begins to fall vertically through the oil. Figure 1.1 shows the ball falling through the oil. Perfect. As the ball begins to fall through the oil, it accelerates. Define acceleration. What will be your definition of acceleration? Acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. Is the rate of change of velocity. Simple as that, nothing complicated. Let's further move ahead. Part B पे आ जाओ बेटा. The mass of the ball is this. Perfect. Calculate the resultant force acting on the ball when it is accelerating downward at a value of this. This is your mass of the ball. This is your acceleration. You have to calculate resultant force. Resultant force is equal to mass into acceleration. Mass is 0.0075 into acceleration, that is 2.8. Can you calculate the resultant force, beta? Resultant force आप निकाल सकते हो. Yes, 0.75 into 2.8. The answer of resultant force comes out to be 0.021 Newton. Simple as that. Let's further move ahead. As the ball falls, its speed v is recorded. Figure 1.2 shows the speed time graph for the falling ball. Perfect. Describe what happens to the acceleration between time t is equal to 0 till time t is equal to 0.04 seconds. So you have to define what is happening to the acceleration of the graph between time t is equal to 0 till time t is equal to 0.04 seconds. Now, do you all remember that the gradient of velocity time graph is equals to acceleration? Beta, do you guys remember that the gradient of velocity time graph is equals to acceleration? If you realize in this yellow highlighted region, what is happening to the gradient? The gradient is decreasing. That means the acceleration is decreasing. Then in this blue region, after time t is equal to 0.03 second, what is happening? Your gradient is 0. Your acceleration after time t is equal to 0.03 second will become 0. So how will you describe this process? This is a basic graph of terminal velocity. How will you describe this velocity time graph with regards to acceleration? You will say, as the speed, I am trying to write as small as possible, as the speed of the ball increases, the resistive forces increase, the resistive forces increase, causing the resultant force to decrease, resultant force to decrease, and hence the acceleration of the ball decreases from time t is equal to 0 till 0.03 seconds. फिर आप बताओगे what happens from 0.03 till 0.04 seconds. From time t is equals to 0.03 seconds till 0.04 seconds, what will happen? The resistive forces equal to the weight. The resistive force equals the weight. Hence, the resultant force becomes 0, acceleration becomes 0. Hence, the resultant force becomes 0, acceleration becomes 0. Simple. Let's further move ahead. By drawing a tangent on figure 1.2, determine a value for the acceleration of the ball at time t is equal to 0.01 seconds. Okay, you have to determine the acceleration of the ball at time t is equal to 0.01 second. Now, beta, I have already told you that the gradient of velocity time graph is equal to acceleration. So we have to calculate the gradient at time t is equal to 0.01 seconds. But can you realize this is a curve? Can you realize this is a curve? How to calculate the gradient of the curve? How to calculate gradient of curve? Have you studied this in mathematics? How to calculate the gradient of a curve? बेटा curve का gradient किस तरह निकालते हैं? Draw a tangent at the specific point. At the specific point, choose two points on the tangent. On the tangent, calculate gradient using those 2 points. Calculate gradient using those 2 points. Simple. Now let's zoom in and do this process. So first of all, we have to draw a tangent at time t is equals to 0.01 seconds. So the point is somewhere here. Yeah, let's draw a tangent at this point. I will try to make sure that the tangent is as accurate as possible, but pardon me for my drawing because I'm very bad at drawing. Okay, so this is your tangent. Let's pick up 2 points here. This is your first point. This is what? 0.019 in the x-axis. And y-axis में क्या होगा? Middle में lie कर रहा है 0.05. What will be your second point? This one. What is this point? 0.005, and y-axis में this will be 0.03. Now, if you are confused as to how I am resolving the axis, let me show you how I am doing that. If you are going from 0.1 to 0.2, how many boxes are you covering? बेटा 0.1 से 0.2 जा रहे हो तो कितने boxes cover कर रहे हो? 10 boxes, 10 small boxes. And how much units are you covering? 0.1 से 0.02, 0.01. So one box equals to how much? 0.001. That's why after 5 boxes, 1, 2, 3, 4, 5, you have an answer of 0.005. And this is 0.019. So you have 2 points, 0.019, 0.05, 0.005, 0.03. Let's write it here. 0.005, 0.03. And the other point is what? भाई दूसरा point कौन सा है? 0.019, 0.019 slash 0.05. Can you calculate the gradient? This is your x1, this is your y1, this is your x2, this is your y2. Can you calculate the gradient? Yep, easy peasy, lemon squeezy. Y2 minus y1 over x2 minus x1. What is y2? 0.05. What is y1? 0.03. What is x2? 0.019. What is x1? 0.05. Can you calculate the gradient? Yeah, you can do that. Let's calculate the gradient. 0.05 minus 0.03. 0.019 minus 0.005. The gradient comes out to be 1.4 meters per second square. Sir, why meters per second square? Because the units of acceleration are meter per second square. This is how you do this question. Let's further move ahead. Let's zoom out a bit. Figure 2.1. Okay, figure 2.1 shows two identical trolleys P and Q held at rest on a frictionless horizontal surface. A load is fixed to trolley P. Okay, so you have fixed a load to trolley P. Perfect. There is a compressed spring between trolley P and trolley Q. Okay, so there is a compressed spring between trolley P and trolley Q. The trolleys are released. As the spring expands, it pushes the trolleys apart. बेटा जैसे ही spring expand हो रहा है, it pushes the trolleys apart. Trolley Q move towards the right at a speed of this. ठीक है ये भी highlight कर देते हैं. Trolley Q is moving towards the right with a speed of 0.36 meters per second. Okay. The mass of each trolley is 1.2 kg. ठीक है भाई इसका मास भी 1.2 kg है, इसका मास भी 1.2 kg है, और यहाँ पे जो लोड है उसका मास क्या है भाई 1.5 kg. So you can write it here 1.5 kg. Perfect. The spring has negligible mass. Perfect. Calculate the speed at which trolley P moves towards the left. You have to calculate the speed at which trolley P moves towards the left. How are you going to do this? But you will say that applying principle of conservation of momentum. You will say apply principle of conservation of momentum. जब आप principle of conservation of momentum apply करोगे, what will you say? The total momentum before the spring expands is equals to the total momentum after. If you humbly realize, initially both the trolleys are at rest. बेटा बिफोर कोलिजन या बिफोर एक्सपेंशन बोथ द ट्रॉलीज आर एट रेस्ट. दोनों की इनिशियल वेलोसिटी जीरो हो गई. If the initial velocity is zero, the total momentum before will be zero. How will you calculate total momentum after? You can see that trolley Q is moving towards the right with a velocity of 0.36. Velocities towards the right can be taken as positive. So mass of trolley Q 1.2 into the velocity that is 0.36 plus what is the mass of trolley P? 1.5 plus 1.2 that is 2.7 multiplied by the velocity of P. Velocity of P is acting towards the left, negative VP. Negative VP. Take this to the left side. 1.2 into 0.36 is equals to 2.7 VP. Can you calculate VP? 1.2 into 0.36 divided by 2.7 is equals to VP. Can you calculate the velocity of trolley P? Yep, 1.2 into 0.36 divided by 2.7. This comes out to be 0.16 meters per second is your velocity at P. Yeah, is your velocity of trolley P. Trolley P की velocity क्या आ गई भाई 0.16 meters per second. If I can somehow manage to shrink this so that it doesn't go out of the page. Let's assume that we are in an examination. Yeah. You have to calculate the kinetic energy of the trolley when it moves at 0.36 meters per second. Beta, kinetic energy of trolley Q निकालनी किस तरह निकालोगे? Kinetic energy of trolley Q is equal to 1/2 mv square. 1/2 into what is the mass of trolley Q? Trolley Q का mass क्या है? 1.2. Okay. 1.2 into the velocity of Q that is 0.36 whole square. Can you calculate the kinetic energy? Easy peasy lemon squeezy. Kinetic energy comes out to be 0.078 joules. Now you have to state the energy transfer that takes place. You have to state the energy transfer that takes place as the spring expands. बेटा जैसे ही spring expand हो रहा है, what happens? The elastic potential energy stored in the spring gets converted into kinetic energy of the trolleys. ये जो compressed spring है, this is storing elastic potential energy. As this spring expands, the elastic potential energy of the spring gets converted into kinetic energy of the trolleys. So you can write it. You can humbly write it. You can say the elastic potential energy of the spring gets converted into kinetic energy of the trolleys. Kinetic energy of the trolleys. Simple as that. Nothing complicated here. Let's further move ahead. Figure 3.1 shows a small block of ice floating in a beaker of warm water. Okay, so this is a block of ice floating in a beaker of warm water. State one way in which the motion of the particles in ice differs from the motion of the particles in water. Okay, how does the motion of particles in ice, that is a solid, differs from the motion of particles in liquid, that is water? बेटा solid में क्या होता है? The molecules vibrate about a fixed position. So you can say the molecules or particles vibrate about their fixed position. Particles vibrate about a fixed position. Vibrate about a fixed position. Simple. Let's further move ahead. Energy is transferred from the water to the block of ice. Okay, energy जो है transfer हो रही है from the water to the block of ice. Okay. State the name of the thermal process that transfers energy from the water to the ice. Whenever two objects are in contact with each other, the energy transfer happens through the process of conduction. Initially, there is 0.34 kg of water in the beaker. The specific heat capacity of uh, water is this perfect. Okay, energy is transferred from the water to the block of ice. I have marked these arrows incorrect. 1 second. क्या कर रहा हूँ ये मैं? Energy is transferred from the water to the block of ice like this. Perfect. The water is warm, that's why. Okay, the specific heat capacity of water is this. Calculate the energy transferred from this water as the temperature decreases from this. Perfect. बेटा एनर्जी का क्या फॉर्मूला लगा सकते हैं? Q is equals to mc delta temperature. What is your mass? 0.34. What is your specific heat capacity? 4200. What is your change in temperature? You are going from 28 to 18. What is your change in temperature? 18 degrees centigrade. Can you calculate this answer? 0.34 into 4200 into 18. Your answer comes out to be 25700 joules. If you convert it till two significant figures, 26,000 joules is your answer. The temperature of the water near the ice decreases first. Explain how convection currents causes the temperature of all the water in the beaker to decrease. अच्छा जी बेटा फर्स्ट ऑफ ऑल क्या हो रहा है? टेम्परेचर ऑफ वाटर नियर द आइस डिक्रीजेस फर्स्ट. मतलब ये जो करीब करीब वाला वाटर है इसका टेम्परेचर पहले डिक्रीज होता है. As the temperature of this water decreases, what will happen? The particles will move close to each other. The volume of these water molecules will decrease. Have we studied this formula? Density is equals to mass over volume. Density is inversely proportional to volume. बेटा अगर आपका volume decrease करेगा, density increase करेगी. This cooler water will sink to the ground. This cooler, more dense water will sink to the ground. What will happen further? Beta, hot, less dense water from the bottom will rise up. Hot, less dense water from the bottom will rise up. Simple as that. Hot, less dense water from the bottom rises up. Cooler, denser water sinks to the ground. Simple. So you can write this entire thing. You can say the water near the ice. क्या कहोगे? The water near the ice. What will happen to the water near the ice? इसको इस तरह लिख लो. The volume of water near the ice decreases, causing the density to increase. This more dense water, they are more dense, cooler water, more dense, cooler water sinks to the ground, sinks to the bottom, कह लो, to the ground, कह लो, sinks to the bottom. And less dense, hot, less dense water rises to the top. Hot, less dense water, yeah, hot, less dense water rises to the top, creating a convection current. Easy peasy, lemon squeezy. Let's further move ahead. बेटा आगे बढ़ते हैं. No. Let's see this. State what happens to the internal energy of the water as the temperature of the water decreases. Describe the change in terms of energy of the particles. So you will say as temperature decreases, the kinetic energy, of particles decrease, what will happen further? Causing the internal energy of particles to decrease. Simple as that. Nothing complicated here. आगे बढ़ते हैं बेटा. क्या लिखा हुआ है? The lens in a magnifying glass is a converging lens. Figure 4.1 shows the lens of the magnifying glass, its two focal points f1 and f2 and its principal axis है. ये f1 f2 है, principal axis है. State what is meant by the focal point. अच्छा, इस focal point का मतलब क्या है? What is meant by this focal point? बेटा focal point का क्या मतलब होता है? Rays parallel to the principal axis after hitting the lens pass through the focal point. बेटा कोई भी ray parallel to the principal axis after hitting the lens passes through the focal point. So you can write it here. Rays parallel to the principal axis, rays parallel to the principal axis pass through the focal point after hitting the lens. So basically focal point की definition ही यही होती है कि वो rays that are parallel to the principal axis after hitting the lens pass through the focal point. Simple as that. Let's further move ahead. A student uses a magnifying glass, sees a magnified image of the object. On figure 4.1, mark a point X on the principal axis for a possible position of the object. Whenever you are using a magnifying glass, object की क्या position हो जाती है? Between the lens and the focal point. So you can mark it here. मैग्नीफाइंग ग्लास के लिए आपकी ऑब्जेक्ट की पोजीशन क्या होती है? बिटवीन द फोकल पॉइंट एंड द लेंस. परफेक्ट. A point E for a possible position for the student's eye. The student will view the image from the other side. maybe from here this is your position E. Underline two words in the list that describe the image in A part 2. बेटा always remember magnifying glass से जो image form होती है it has three properties. It is virtual. Magnifying glass से जो image form होती है उसकी three properties होती हैं. It is virtual, it is upright. Third property क्या होती है बेटा? It is magnified as the name suggests. तो यहाँ पे कौन कौन सी प्रॉपर्टीज हैं? अपराइट है, वर्चुअल है, टेक दैट एंड मूव फॉरवर्ड. द रिफ्रैक्टिव इंडेक्स ऑफ द ग्लास यूज टू मेक द लेंस इज दिस. अच्छा जी, ये आपका रिफ्रैक्टिव इंडेक्स आ गया. द स्पीड ऑफ लाइट इज दिस. कैलकुलेट द स्पीड ऑफ लाइट इन ग्लास. सो व्हाट विल यू से? Refractive index is equal to the speed of light divided by the speed of light in glass. रिफ्रैक्टिव इंडेक्स है बेटा 1.5. स्पीड ऑफ लाइट इन एयर क्या है? 3 इंटू 10 इज द पावर ऑफ 8. स्पीड ऑफ ग्लास क्या है? ये आ गई. जस्ट रीअरेंज द फॉर्मूला. द स्पीड ऑफ लाइट इन ग्लास इज 3 इंटू 10 इज द पावर ऑफ 8 डिवाइडेड बाय 1.5 is equals to 2 into 10 raised to the power of 8 meters per second. Simple as that, nothing complicated here. आगे बढ़ते हैं बेटा. State what happens to the wavelength of light as it passes into the lens. बेटा जैसे ही आपकी लाइट लेंस में एंटर करती है इट्स स्पीड डिक्रीजेस. Have we studied v is equals to f lambda? As the speed decreases, wavelength also decrease. Wavelength decreases. Simple as that. ये प्रॉपर क्या हो रही है? ये रिफ्रैक्शन का प्रोसेस हो रहा है. As the light is traveling from air into the lens, रिफ्रैक्शन हो रही है, वेलोसिटी कम हो रही है, वेवलेंथ कम. Converging lenses are used in spectacles to correct one problem with vision. अच्छा जी, converging lenses use होते हैं to correct our vision. Perfect. State the name of the problem and explain how a converging lens is used to correct it. बेटा कौन सी प्रॉब्लम को converging lens जो है सुधारते हैं? लॉन्ग साइटेडनेस को. Always remember converging lens solve long sightedness. Diverging lens कौन सी प्रॉब्लम को सॉल्व करते हैं? Which problem do diverging lens solve? Short sightedness. Short sightedness. और converging lens कौन सी प्रॉब्लम को सॉल्व करते हैं? लॉन्ग साइटेडनेस को. परफेक्ट. सो नाउ यू हैव नेम्ड द प्रॉब्लम. नाउ एक्सप्लेन कि ये लॉन्ग साइटेडनेस को किस तरह से सॉल्व करते हैं. ठीक है. द कन्वर्जिंग लेंस focuses the image back on the retina. The converging lens focuses the image back on the retina. ठीक है. Converging lens क्या करता है? Focuses the image back on retina. Simple. यहाँ पे आप और भी लिख सकते हो since it is a 3-marker question. Since long sighted, or you can write it like this. Since long sightedness causes the image to be formed behind the retina. So I think ये लास्ट वाला पॉइंट हम पहले लिख देते हैं और फर्स्ट वाले पॉइंट को हम आखिर में लिख देते हैं. Let's keep this to the top and this to the end. Yeah, this looks like a better answer. Perfect. Describe how a longitudinal wave differs from a transverse wave. Very, very easy. First of all, longitudinal wave के बारे में लिख देते हैं. Longitudinal wave. Longitudinal wave में क्या होता है बेटा? The direction of vibration या oscillation is parallel to the direction of wave travel. The direction of oscillation या vibration is parallel to the direction of wave travel. ठीक है? Now, ट्रांसवर्स वेव में क्या होता है? आई थिंक आई विल हैव टू स्टार्ट ट्रांसवर्स वेव फ्रॉम दिस लाइन ओनली, क्योंकि स्पेस थोड़ी सी कम है. ट्रांसवर्स वेव में क्या होता है बेटा? द डायरेक्शन ऑफ वाइब्रेशन या फिर ऑसिलेशन इज perpendicular is perpendicular to the direction of wave travel, to the direction of wave travel. Simple as that. Figure 5.1 represents a seismic wave produced by an earthquake. Suggests whether the seismic wave is a P wave or an S wave. बेटा अभी एक चीज अपनी कॉपीज में लिख लो. Seismic P waves are longitudinal waves. Seismic P waves are longitudinal waves. Seismic S waves are transverse waves. From the diagram, can you see that this is a longitudinal wave? Longitudinal wave. Hence, it is a seismic P wave. Simple. The wave represented in figure 5.1 has a wavelength of this. You have to calculate the actual distance between J and K. How will you calculate the actual distance between J and K? Very easy. This is compression, this is compression, this is rarefaction. Do you remember for a longitudinal wave, the distance between two compressions is lambda. The distance between compression and rarefaction is half lambda. So from compression to compression, you have lambda. Then from compression to rarefaction, you have half lambda. What will be the total distance between J and K? J and K के बीच का total distance क्या होगा? Lambda plus half lambda. This comes out to be 3 over 2 lambda. Lambda की value क्या है? 1.2 10 raised to the power of 4. 3 over 2 into 1.2 into 10 raised to the power of 4. Can you calculate this answer? 1.8 into 10 raised to the power of 4 meters is your distance. Simple as that. Let's further move ahead. The wave in B travels with the speed of this. Okay, this is the speed of the wave. As the wave passes a certain point, the ground completes 5 oscillations. Okay. Calculate the time it takes for the wave to pass. Okay, show your working. First of all, we will apply V is equals to F lambda. Then rearrange this equation. In place of frequency, what can I write? 1 over time period. 1 over time period into lambda. Can you calculate the time period ki value? Lambda divided by velocity. What is your value of lambda? Wavelength ki value kya hai beta? 1.2 10 raised to the power of 4. 1.2 10 raised to the power of 4. What is your velocity? 4600. Can you calculate the time period? Time period nikalo. 1.2 10 raised to the power of 4. 4600. Time period comes out to be 2.6 seconds. This is the time taken for one oscillation. You have to calculate the time for 5 oscillations. अगर one oscillation 2.6 seconds में हो रही है, 5 oscillations x seconds में होंगी, 5 into 2.6, what is your answer comes out to be? 13 seconds is your total time. Let's further move ahead. Figure 6.1 shows an isolated metal sphere suspended by an insulating thread from the ceiling. Perfect. The sphere is negatively charged. The charge on the sphere produces an electric field in the surrounding. State what is meant by an electric field. You will say a region in a space around a charged particle. A region in a space around a charged particle. Around a charged particle. Where another charge experiences a force. Simple. Draw on figure 6.1 to show the pattern and direction of the electric field line produced by the charge on the sphere. Draw at least two lines. बेटा ये negatively charged sphere है. So how will your field lines be? Into the negative charge. हमेशा याद रखो, whenever you have a negative charge, your electric field lines will act into the page. So you have to draw four field lines. So let's draw five just in case, just to be over smart. Yeah. All of the arrows will point inwards. And see 3 marks for this. How easy IG physics is. The magnitude of charge on the sphere is this. An earth wire is touched against the surface of the sphere and the sphere discharges. State what happens to the wire as the sphere is discharged. ठीक है, हमने बताना है state what happens in the wire as the sphere is discharged. बेटा once you apply an earth wire, जैसे ही आप इस स्फीयर के साथ एक अर्थ वायर लगाओगे, व्हाट विल हैपन? इलेक्ट्रॉन्स विल फ्लो फ्रॉम द स्फीयर इनटू द अर्थ थ्रू द अर्थ वायर. क्या होगा? स्टेट व्हाट हैपेंस इन द वायर एज द स्फीयर इज डिस्चार्ज. जैसे ही आपने यहाँ पे एक अर्थ वायर लगाया, लेट मी एक्चुअली पुट एन अर्थ वायर हियर. लेट्स से आपने यहाँ पे एक अर्थ वायर लगा दिया. दिस इज हाउ एन अर्थ वायर लुक्स. यहाँ पे जो नेगेटिव चार्जेस होंगे, they will flow from the sphere into the earth. So you can say the electrons move from the sphere, move from the sphere into the earth, into the earth. Simple as that, nothing complicated here. It takes a time of 0.14 nanoseconds for the sphere to discharge completely. You have to calculate current. Current is equals to charge over time. What is your charge? 3.5, 10 raised to the power of minus 10. What is your time? 0.14 nanoseconds. ये small n क्या है बेटा? Nano. 10 raised to the power of minus 9. 10 raised to the power of minus 9. Can you calculate the current? हाँ जी, current निकाल सकते हो आप. 3.5, 10 raised to the power of minus 10.14, 10 raised to the power of minus 9. Can you calculate the current? 2.5 ampere is your current. Simple as that, nothing complicated, easy. The electromotive force of the battery is 7.5. Define the term electromotive force. You have to define the term electromotive force. What will you say? Work done per unit charge in moving a unit charge across the complete circuit. You will say work done per unit charge in moving a unit charge across the complete circuit. Perfect. Let's further move ahead. The battery is connected in series with a variable resistor. Perfect. A 30 ohm resistor. Perfect. The battery is made using 1.5 volt cells. Okay. Draw a circuit diagram that shows all the 1.5 volt cells connected to produce an EMF of 7.5. बेटा 1.5 वोल्ट के सेल्स को किस तरह लगाओगे कि 7.5 बन जाए? इन सीरीज, लाइक दिस. हाउ डू यू कनेक्ट सेल्स इन सीरीज? बेटा सेल्स को सीरीज में किस तरह कनेक्ट करते हो? नेगेटिव विद पॉजिटिव, नेगेटिव विद पॉजिटिव, नेगेटिव विद पॉजिटिव, नेगेटिव विद पॉजिटिव. These are 5 cells, 1.5, 1.5, 1.5, 1.5, 1.5. Total ये क्या हो जाएगा? 7.5. You connect a 30 ohm resistor with it, like this. And then you connect a variable resistor with it, like this. ये आ गया आपका variable resistor. सिर्फ सर्किट को बंद कर दो, you have your circuit. Always remember, if you have one 1.5 वोल्ट सेल इस तरह से, अगर आप इसका नेगेटिव टर्मिनल दूसरे के पॉजिटिव के साथ कनेक्ट कर दोगे, टोटल वोल्टेज ऐड अप हो जाएगा. इट विल बिकम 3 volts. Similarly, I have connected 5 cells here. 5 multiplied by 1.5, that is 7.5. Simple. The resistance of the variable resistor can be varied from 0 ohm to a maximum resistance of 150 ohm per phase. Use the axis in 7.1 to draw a graph to show how the current in the circuit varies as the resistance of the variable resistor increases from 0 to 150 ohms. Determine and label the value of the maximum current on the y-axis. बेटा first of all तो मुझे ये बताओ कि variable resistor can vary its resistance from 0 to 150 ohm. When will the maximum current occur? बेटा maximum current in the circuit कब occur करेगा? When the resistance of the variable resistor is 0. इस resistor की resistance तो अभी भी 30 ohm है. Total resistance क्या हो जाएगी? 30 ohms. What is your total voltage? 7.5. V is 7.5 volts. R is 30. Can you calculate the maximum current? V is equals to I max RT. V क्या है 7.5. I max हमने निकालना है. RT क्या है बेटा 30. 7.5 divided by 30. Calculate the current. I max. निकालो करंट क्या आता है भाई 7.5 divided by 30. करंट की वैल्यू निकालो भाई. The current comes out to be 0.25 ampere. This is the maximum value of current. Beta, what will happen as you increase the resistance of the variable resistor? आपकी total resistance increase करेगी, current decrease करेगी. Let me show you practically as well. बेटा जैसे जैसे आपकी वेरिएबल रेजिस्टर की रेजिस्टेंस इंक्रीज करेगी और टोटल रेजिस्टेंस की वैल्यू इंक्रीजेस 30 से लेट से 50 60 70 इस तरह होती जाएगी. As the value of total resistance increases, ये increase करेगा. Current maximum की value will keep on decreasing. Basically, you have an inverse graph like this. Simple. The isotope thallium-208 is radioactive. It decays by beta decay. Thallium-208 decays to form an isotope of lead. Complete the equation for this decay. अच्छा जी ये beta decay हो रहा है. We have to complete the equation for this. How will we do that? अगर बीटा डिके होता है तो आपका मास नंबर सेम रहता है. प्रोटॉन नंबर इंक्रीजेस बाय 182. व्हाट विल हैपन हियर 0 -1. The beta emission of thallium-208 is accompanied by gamma emission from the nucleus. State why gamma emission does not affect the numbers in equation A1. बेटा गामा emission जो है वो numbers in A1 को क्यों नहीं affect करती? हाँ जी, because gamma has no mass, no charge. Gamma emission has no mass slash charge. Simple as that. Suggest one reason why the nucleus of thallium-208 is unstable. भाई thallium का nucleus unstable क्यों है? Because can you realize thallium में there are many neutrons. थैलियम अच्छा थैलियम के न्यूक्लियस को जरा एनालाइज करते हैं. इधर ले आओ इसको जरा इसके न्यूक्लियस को 208 81 थैलियम. इसके प्रोटॉन्स कितने बेटा 81. कैन यू कैलकुलेट द नंबर ऑफ न्यूट्रॉन्स 208 माइनस 81. नंबर ऑफ न्यूट्रॉन्स कितने हैं 127. कैन यू रियलाइज दिस न्यूक्लियस हैज टू मेनी न्यूट्रॉन्स. बेटा अगर एक स्टेबल न्यूक्लियस है ना ऑलवेज रिमेंबर एक स्टेबल न्यूक्लियस में यहां पे मैं लिखवा देता हूं. फॉर अ स्टेबल न्यूक्लियस द प्रोटॉन टू न्यूट्रॉन रेशियो इज 1:1. यहां पे देख रहे हो न्यूट्रॉन्स बहुत ज्यादा है. द प्रोटॉन टू न्यूट्रॉन रेशियो इज मच मच ग्रेटर. तो यू कैन से द प्रोटॉन टू न्यूट्रॉन रेशियो, या इस तरह नहीं लिखना चाह रहे तो यू कैन से द thallium-208 nucleus contains too many neutrons. Too many neutrons, hence unstable. Simple. हमेशा एक स्टेबल न्यूक्लियस में प्रोटॉन टू न्यूट्रॉन का रेशियो 1:1 होना चाहिए. A sample of thallium-208 is placed in a thick lead container. Figure 8.1 shows a narrow beam of beta particles and gamma radiation emerging from a small hole in one side of the container. ठीक है, beta particles और gamma radiation यहाँ से निकल रही है. Magnetic field is into the page. The narrow beam enters a region where there is a magnetic field that is directed into the page. On figure 8.1, draw a line labeled beta to indicate the part of beta particles in the magnetic field. अच्छा जी, फर्स्ट ऑफ ऑल तो आपने बीटा पार्टिकल्स का बताना है कि हाउ विल दे ट्रैवल. बेटा कैन यू हम्बली रियलाइज कि यहाँ पे आपने क्या बताना है, डायरेक्शन ऑफ फोर्स. वेन एवर यू हैव टू कैलकुलेट डायरेक्शन ऑफ फोर्स कौन सा लॉ लगाते हैं, फ्लेमिंग्स लेफ्ट हैंड rule. Now, according to Fleming's left hand rule, your first finger points into the page. This is your magnetic field. Where will your second finger point? Beta particles are pointing towards the right. Beta particles are negative particles. Always remember that direction of current is opposite to direction of negative charges. तो बेटा ये नेगेटिव चार्जेस या बीटा पार्टिकल्स तो राइट की तरफ ट्रैवल कर रहे हैं ना, ये राइट की तरफ ट्रैवल कर रहे हैं. व्हाट विल बी द डायरेक्शन ऑफ करंट, टुवर्ड्स द लेफ्ट, लाइक दिस. वेयर विल योर थंब पॉइंट. बेटा अगर आप फ्लेमिंग्स लेफ्ट हैंड रूल लगाओ, मैग्नेटिक फील्ड इनटू द पेज, करंट टुवर्ड्स द लेफ्ट, where does your direction of force point, where does your thumb points, thumb points downwards. How will you make the line for beta particle like this? This is your beta. Draw a labeled line for gamma. How will you draw a line for gamma particles like this? इस तरह से. Simple. Gamma का भी बना लिया, बीटा का भी बना लिया. Simple. Let's further move ahead. The sun is one of many billions of stars in the Milky Way. The sun emits a very large quantity of energy as electromagnetic radiation. State the three regions of electromagnetic spectrum in which the sun emits most energy. Infrared, ultraviolet, and which else? एक लास्ट होती है विजिबल लाइट. इन तीन रीजन्स में जो है वो सन जो है सबसे ज़्यादा एनर्जी इमिट करता है. Electromagnetic radiation from the sun travel at a speed of this. The radiation reaches sun in 500 seconds. Calculate the distance. Distance is equal to velocity into time. Velocity क्या है, 3 into 10 is the power of 8. Time क्या है, 500. Can you calculate the distance? Yep. Can you calculate the distance? 1500 into 10 is the power of 8 meters. Simple as that. B is your answer. Nothing complicated here. Let's further move ahead. Approximately 4.6 billion years ago, the sun formed an interstellar cloud of gas and became a stable star. Describe and explain what happens as an interstellar cloud of gas forms a protostar. बेटा हमने बताना है कि cloud of gas से आप protostar की तरफ कैसे जाते हो. क्या होता है? The cloud of gas collapses due to the internal gravitational attraction. जैसे ही cloud of gas collapse करता है या inward move करता है, the number of collisions increases, the temperature increases. So how will you write that? The cloud collapses inward due to gravitational attraction. Gravitational attraction. This causes the temperature to increase as collision frequency increases. Describe and explain what happens as a protostar becomes a stable star. भाई protostar जब stable star बनता है तो क्या होता है? Let's see. हाँ, क्या होता है? The outward force due to high temperature is balanced out by the inward gravitational force. The forces are balanced. Hence, you have a stable star. The outward force due to high temperature is is balanced by inward gravitational force. Gravitational force causing the star to be stable. Simple, easy peasy, lemon squeezy. This paper is finished. I hope everything was clear. If you have any questions, you can ask.